Andrew is racist.
It's recording.
Everyone's not supposed to know.
Andrew? Oh, he didn't distinguish which Andrew.
Oh, yeah.
Okay.
Oh, fair enough. Dodged a bullet. What's going on, smart people? I put up a poll on the community tab saying, what questions would you like to ask grad students? Some of these questions are going to be addressed in this weekly vlog. Most of them are going to be put in a separate video, which will be up for the 30,000 subscriber special, if you want to call it that. So I have a bunch of our fellow grad students with us today. Everyone want to introduce yourself? Where's my coffee?
Hi, I'm Elijah.
Hi, I am Abhishek.
I'm Andrew.
Hi, I'm Krishna.
Hi, I'm
Okay, good. Yeah, I figured you guys always hear what I have to say, but it'd be nice to get the different grad students' perspectives for all of your questions. So there's 128 questions that you guys posted. How I'm going to organize this is we're going to sort from the most upvoted, so the ones that a lot of people wanted answered, and then after those stop being distinguishable, we'll sort by which ones posted first. So let's get started with the first one. Giovanni Carmona, what was your or their worst experience with academic failure, and how did you bounce back? That one got 30 likes. So,
Oh boy.
any big academic failures come to mind?
Well, I'm just a big academic failure in general. And I bounce back every day with alcohol. So.
Great start.
I got a D in Spanish 2, and I got it written off so that I could graduate.
Now, I would honestly say my biggest one, my freshman year of college, when I was still a biology student, I got a D in English. And then I changed majors to physics.
What grade did you get in English, Abhishek?
English. We did not have English major, English class in the college, but my biggest academic failure till date was right after I completed my master's in India. I got rejected from all the grade schools, and that was the biggest setback for me. So for a year I could not study, and after that I was admitted to the NMSU.
Yeah, the trick is to shoot low, and then you're not let down.
Yeah, grad applications definitely were a huge hit to the ego.
Yeah. For me, so on a more serious note, my biggest academic failure was that I accidentally published a paper without my research advisor reading that.
And it was accepted?
It was accepted and published, and
published,
so
okay.
I mean, good news is I got published. Bad news is my research advisor was upset with me, but that was in an undergrad. So basically, the way I bounced back was time. I still feel a bit hurt from that because my research advisor felt very much that it was my fault, and it took a lot of time to realize that it probably was something that I did.
Was it wrong?
Well, the paper was bad. I'll admit the paper was not great. And had he taken the time to read it, it would have been a lot better. But I talked to a bunch of people about it, got advice because it was something that really kind of hurt me. Was I felt like kind of abandoned that my research advisor blamed me for it. And I talked to a lot of people, and they all said, you're in your undergrad. This is by no means going to ruin your entire life. So, and here I am at grad school, so that's fine. It all turned out eventually.
What about you, Krishna? Anything coming to mind?
I screwed in some of the physics exam in my past.
Sure.
I bounced back after then. So yeah, I mean,
How did you bounce back?
maybe I studied more and I started understanding the questions or like the physics.
Yeah.
That's how.
My failure was just right after the high school when I just admitted to the college, and at that time I passed all the subjects, but I was failed in English.
We're one and the same.
There we go.
Maybe you have a better
And
excuse.
another thing is so during the TOEFL exam when I was applying for the grad school.
Oh,
I
yeah.
I was failed at the first attempt.
Oh yeah, I was failed.
I scored like at least 80.
In the second time I got.
Qualifier definitely hurt a little bit. Too.
Oh my god.
Oh no, yeah.
Yeah, let's not talk
that's
about
a
that.
big one.
Moving on.
Yes, please.
Ben Prusick, is it ever intimidating knowing all the great minds that have come before you in physics? So just being surrounded by smart people. You guys find that intimidating?
I'd say I mean, not necessarily intimidating. It definitely makes our work harder because, like, most of the low-hanging fruit has been picked and eaten already. So you have to really search for the new science. And it basically, we have all these cool tools that make it so much easier with our high computation power and everything, and all the knowledge of all those great minds that they found. But we have to work a whole lot harder to find anything new.
Oh, I read the question wrong. I thought it was being like, you're
Like
in
your
grad school next to
professors.
smart people.
Yeah.
Is
Oh,
that...
No,
No,
they mean,
yeah,
they mean
no.
like, does it intimidate you knowing Newton and Einstein existed?
Yeah, and at the same age, they were
Yeah.
doing all their amazing
Yeah,
things,
like
basically.
for like me, it's not that intimidating. It's just I
kind
know
of
that I'm
encouraging.
not at their level, you know.
Inspiring.
It's inspiring.
It's
right?
inspiring,
Yeah,
yeah.
it's
For sure.
inspiring.
Yeah.
Rather than
Use it as a motivation, not
Yeah,
as something
yeah.
that's gonna drag you down.
What math courses would you recommend for a physics major in undergrad but unsure which area to go into? So I have a comment about this. I think every physics student in undergrad should probably pick up a minor in math, because any check in the list of a minor in math is the basic math that you're for sure going to use in physics, whether that's your multivariable calculus, differential equations, linear algebra. Those are the big ones. And then the rest, you can always benefit from taking like real analysis or, I don't know, maybe like a statistics course.
Yeah,
So
statistics would be great, right?
if you go with getting a minor in math, a lot of the
Yeah.
things that you need to have will already be taken care of for you. And any of the more advanced areas of mathematics, like if you're talking about group theory or differential geometry or something, that has a way, or it seems to have a way of sorting itself out in the courses, say in grad school, that you'd be taking that use that. So if you use a new branch of math in a physics course, in my experience anyways, they'll teach you it in the physics as the way a physicist would use it.
I feel like they'll touch on it. And
Yeah,
then,
they'll-
and then
They'll do a
expect that you-
1-week summary
Yeah,
of
which is
a
good,
semester.
But yeah, the fields that were most important to me was partial differential equations. That was a wonderful class, but
For the mathematics, I have the different feeling. Like, if you ever feel like going in the theoretical physics, do not study mathematics just as a tool. Then it's really hard to digest all the stuff. If you really want to be a theoretician, especially in the particle physics, study the mathematics as an whole subject, not just like you will be using it in just physics. No, understand it fundamentally, then the physics will make more sense to you. Because if you look at the last 20 years in the particle physics, most of the stuff they are doing is higher mathematics with a little bit of physics in it. So if you don't know the mathematics fundamentally, you will never be able to grasp all those stuff.
Yeah.
It's like the equivalent of how we always use like residue theorem or something, but that's
Yeah.
always towards the end of a complex analysis book.
Yeah,
It's like
exactly.
there's so much that comes before that.
Yeah.
Okay. Those of you doing research, so singling me out of not doing research, those of you doing research, how did you decide on your research topic, and how do you usually go about doing the research?
Well, I sort of just fell into it. I didn't know what I was going to do after undergrad, and I started talking to professors, and I knew this one professor from undergrad that had some cool posters up and stuff. Just kind of talked to him and was kind of told what to research. And then, like, how I go about it now is in a very unorganized way. Just kind of play around with a bunch of data, and then I have to present it, and so then I go back and do a lot of literature review to figure out what I actually was doing in my analysis.
So what is your research in?
It's basically material science using X-rays and neutrons.
Mm-hmm. All right.
Yeah, well, I did an internship in my undergrad, and one of the professors that I worked with at that internship got a job here. So I just kind of followed suit and followed her here, and that's where I got my research in seismology. How do I go about doing it nowadays? Basically chaotically, just looking into anything and everything. Some days I'll spend a couple hours just looking into how MATLAB works, more special functions that might make my code more efficient. So I do a lot of computational work with seismic waves. So, and then when you have to present, you do a lot of lit review so that you understand kind of what's being done. In lit reviews, you know, the people that actually publish papers usually have a really good way of explaining what you're doing, and you just kind of go from there.
What about you guys?
Actually, for my case, the main thing is where you are interested. So actually, are you interested on like which kind of field, like particle physics, or in our university we have like mainly two branches of research, like in particle physics, theoretical, and the experimental condensed matter and theoretical condensed matter also. So it's depend on where you interested.
Those undergrad projects are a good way of finding out if you like doing research in the first place too.
Yeah.
Because you might like a topic in physics, but then when it comes down to actually conducting research, you're like, wow, I feel clueless all the time. I don't want to do that for my career.
Yeah, and it tends to be like less pressure.
Yeah.
It's not like you're being paid a lot of money or
Yeah.
something to do that research.
Yeah, it's the best advice.
Good way to test.
As like a freshman, look for research, and if you're not a freshman, don't feel like it's too late. Just find something to do, and see if you like it.
Krishna?
I think it's basically depend on the interest, right?
Sure.
In which area you are interested. So I choose the professors. I was interested in material science. So there is like two options. One is like experimental and another is theoretical. And I went to the theoretical part because I was I like to play with the computers, and then my kind of work is like in the computer, data analysis, and like to find the structures.
So it says, how did you decide on your research topic? So I think the general consensus is like, the best way to try is to either do some research in something, because you can either narrow it down, or you could get lucky and try something and just automatically like it. So when I did my first research internship, it was REU at Jefferson Lab in accelerator physics. And it was kind of fun. It was cool, but I knew I didn't want to pursue that professionally. Then I did another REU at Jefferson Lab in the nuclear theory department. I was like, okay, this is cool. I like playing with this math more. At that stage, I think for most internships, any knowledge that you get is going to be kind of surface level. Like I did an internship in like theoretical, quantum chromodynamics, but I didn't know it at all. I just did kind of what my research advisor told me to do, and then tried to internalize as much as I could. But that's just, do you like doing what you're doing, even if you don't really understand it at that point? I think that's a good indicator. What about you, Abhishek? Did you already go?
I haven't started research here, but when I did my master's, I did a review project on finite temperature quantum field theory, and then I was looking for the application of those stuff, and I stumbled upon the neutron stars, and that's when I found that nuclear astrophysics is really cool stuff. Because it's a mixture of the you need to take care of all the things which you ignore in the quantum chromodynamics. If you have the QCD, you apply that QCD, and then you need to determine at what level the gravity overcomes the QCD. So this was really intriguing, and I find it fascinating. That's why I started with the nuclear astrophysics, and especially on the neutron stars.
What's the one skill you wish you had learned earlier / got more experience in high school, like in high school, that would benefit you greatly during grad school?
Computation,
Yeah.
all the way.
That's a good one.
That's basically
For sure.
I mean, even within college itself too. Like,
Yeah.
just the 2 classes I took on it wasn't necessarily enough. It wasn't really until I started doing research that I realized how important it was.
Yeah.
And since I really had to use it for like my own things, I learned it a lot better. But if I would have known like how coding works,
Yeah.
and just like how computation works in general,
Yeah,
coming into college, I would have had a much better start. Yeah.
I second that one. I think that's a good one.
Yeah. Making that leap between how you represent a function and code versus how you represent it in mathematics takes a bit.
Okay. Here's my question: when did you guys realize that physics is your passion, not some other subject? And which topics do you find the most challenging? Okay. So when did you realize that physics is math? I actually have a pretty cool story about this. So back when I was still a biology major at VCU, I would come home on break, and I'd go over to like my dad's house or something like that, and we'd talk, and I'd talk about something that I saw on like Cosmos or Into the Universe with Stephen Hawking, and we would talk about that. I'd talk about black holes. It's all pop science stuff, but it was fun for me to talk about. And then at one point, my dad was like, when you come home, when you visit, you're never talking about how cool the brain is or how plants work. You're always talking about this stuff that you see on TV with Neil deGrasse Tyson and Hawking. So he kind of planted the seed. There was like, I think you might have picked the wrong major. I think physics would have been more for you. And then here I am now. So what about you guys?
I didn't have that fascinating
Yeah.
story, but
Yeah, mine's not great either. Yeah, basically I was like, oh, freshman orientation, what do you want to do? Well, I guess they got physics. I'll try it.
Okay, so well, what about topics that you find challenging in physics? Or let's say physics and math. Are there specific areas? I've always struggled with classical mechanics, I'd say. I think that's my toughest.
I mean, I've always just loved like qualitative physics. I'm a lot worse when it comes to actually computing things, and I like just understanding how things work in my head, but I don't really think in equations. I think more in like images and sort of like simulations, in my head. So like,
Interesting.
theory in general is hard for me. I like playing with physics that we already know and like using cool toys to discover new physics or help discover new physics. But thinking in terms of equations isn't really my thing. So.
What about you guys?
For
Any
my
specific?
case, it's quantum mechanics is kind of non-intuitive. So
Quantum?
if somebody knows, like, so you cannot predict the exact position of quantum particle like electron. We are like thinking classical way. If somebody says like that to the students from like high school, they will kind of like surprised. So it's kind of non-intuitive. So I think quantum mechanics is more challenging.
Yeah.
I think quantum started to become more intuitive to me when I stopped thinking about that and just started thinking in terms of like complex vector spaces and linear transformations. I'm like, now I understand. Of course it does this.
Yeah. For me, quantum's one of the more difficult subjects to grasp. But then all of a sudden, I feel like at a certain point, it just clicks, like quantum.
Yeah.
Not entirely, but like
never fully.
Never
clicks,
fully, but it becomes all of a sudden, your mind shifts to understand just like smaller bits of it that you just didn't make sense before. Other than that, E&M is probably for me like the most difficult consistently.
The most difficult for me is to digest that in quantum field theory you can make particles out of nowhere.
Oh yeah, that really surprised me too.
That is really hard to digest when you start learning the quantum field theory. That you are in a vacuum and all of a sudden you can start creating particles out of vacuum.
It's crazier also when you have a particle and then you just convert it into an antiparticle with the charge conjugation operator. I'm like, okay.
That's beyond me. I don't know anything about that.
I knew it was physics when I was in chemical engineering and physics, and it was like I only enjoyed the first like 2 weeks of the chemical engineering classes when they actually tell you the physics, and then the rest of it is just using it.
How do good on GRE? Not the person to ask.
Not me either.
Hire somebody. Go to a tutoring center.
How do good in GRE?
How to do good in GRE? Definitely.
I mean,
practice it.
Yeah,
Practice.
look at all the old
Practice
exams
it.
and learn all of the tricks.
Practice more problems without using calculator.
So I did terribly the first time around on the physics GRE, and that's because I studied. Well, one, I didn't give myself very much time to study, and the second is I studied by making sure I could derive everything from first principles. That's not how you go about the physics GRE. On average, you have 2 minutes per question or something absurd like that. So the next time around, I got the Conquering the Physics GRE textbook, and that was so much better because they let you know what types of this topic questions are going to be asked. They emphasize like limiting cases and dimensional analysis, and there's practice exams in it. So I think that's crucial. I still didn't do that great
I
on the
think
physics
so.
degree,
In
but
physics GRE, you cannot derive stuff. So make sure there is a Cambridge handbook for physics formulas. You cram most of the formulas out of that book, and then you are good to go for physics GRE.
Yeah, it's less of an exercise in physics and more of
Yeah.
an exercise in test taking.
Yeah.
Sure.
And when I took it, they've changed it since. They no longer take points off for wrong answers
Yeah.
anymore.
Oh,
so
yeah.
guess at everything.
Yeah.
And if you can eliminate questions or eliminate some of the answers, just try your best to do that. I know one of the pieces of advice that I was going into it with was do your dimensional analysis, see if the units check out on the answers.
Yeah.
I heard that's not as big
Yeah,
of a thing
they,
anymore.
they pretty much always make the units right now.
Yeah, because that was a big thing for getting free points. Basically, was dimensional analysis.
Yeah.
But I guess just small tricks. Try to take the practice GREs and see what the small tricks are.
Have a good internal timer. Know when you're
Yeah.
spending too
Yeah.
much time on a
So
problem.
yeah, we
and
need to
move on.
manage the time very
Yeah.
cleverly.
Yeah,
Because
I
that
took-
is the problem of time management, right?
Yeah.
So we can, I mean, if they give like 5 hours, 6 hours, we can solve entirely whole questions.
Yeah.
Mm.
But
870
Yeah.
minutes.
yeah,
okay. How often do you guys find yourselves procrastinating?
always.
Well, we're making this
Always.
video right now.
When was the last time I didn't procrastinate?
So instead of doing what I should be doing, I'm making a YouTube video.
I still needed to get this done today, so I guess technically I'm not procrastinating.
Yeah.
I have.
But you're helping us procrastinate,
Good
which is
job,
great.
Dotson.
Thanks.
I'm an enabler.
That's how we help each other in the grad school.
I don't know. I watch my daily PewDiePie video, and then I don't think I procrastinate too much. I think.
Yeah, I could see that. You're very efficient.
It shows in the grades.
So, yeah. What is the main difference between undergrad and grad students?
Smarter. No,
The-
I'm just
the
kidding.
amount-
No, there's some undergrads that I'm like, dang, like, what do you know? You know too much.
Can you help me with my homework?
Yeah.
The amount of gray hair, I would say.
Yeah. Or the
I'd
amount of
definitely go
hair
with
in
gray.
general.
The difference between.
I'd say I sleep more as a grad student, but I'm more stressed out. I feel
More
like I was
stressed out.
pulling
Oh, yeah.
more all-nighters as an undergrad just because the homeworks would have a lot of volume to them. Now it's just like you sit for like 2 hours on one problem
Yeah.
trying to figure it out.
Oh yeah.
I feel like there's less homework as a grad student, but there's also more stuff to do because you're teaching. You know, you're making up that time, and it's a pretty equal balance. You're still working your butt off as an undergrad, but grad school is a different kind of working your butt
And there's
off.
more independence. It's like you
Yeah.
have to decide how to use your time a little bit better. It's dictated to you less.
I think so. In undergrad, you don't need to stress your brain too much. In grad school,
Also, I think
Yeah.
if I were to turn in a homework problem in undergrad with one of the problems just not answered, I feel like I'd get away with that easier than in grad school. So
Yeah.
I don't know. Now I feel more like I have to. No matter, don't leave anything blank.
yeah, because one problem might be 7 points. Just
Well,
like
that too.
CG coefficients.
I'm
If
speaking-
You,
Well, yeah.
if you put it blank, you are losing 70% of your points.
Well, the good news about that one is it's not technically hard. It takes forever.
Yeah.
Okay. What personal sacrifices have you made in pursuing your education?
Mental
Personal
sanity.
It's not
Don't-
exactly a stress-free environment.
Don't exercise.
Overall, good feelings are one of my
I
sacrifices.
drink more coffee than water.
That's true.
Same. I drink more coffee than water, and I drink more beer than coffee. So.
Yeah, I definitely had a lot. I have a lot of hobbies that I haven't been able to do since grad school. Like, I go to the gym way less than I used to. I used to play RuneScape all the time, and I haven't played since grad school started.
Video games.
I used to play my instruments all the time, so it's like I don't get bored because if finally there's a break from grad school stuff, I can finally go back to that stuff.
Yeah.
But I think any hobbies that you've taken up over the years, you get to do it less, which I think is
Yeah, you're gonna get less good at your hobbies.
Is time management? I just spit on my computer. Is time management in grad school really doable? I'm going to go ahead and say that is the only way to do grad school is to know
Yeah.
how to manage your time. what are the few commitments that you had to sacrifice, like hobbies, in order to do decently in grad school? Any tips?
What was the question?
Is time management doable?
Mm-hmm.
What are the few commitments you've had to sacrifice, or like, have you had to sacrifice hobbies, or I don't know,
Yeah.
things in a daily routine that you can't really
Sometimes
do
you have to
anymore?
sacrifice, right?
Yeah.
I mean,
right. My dating life, you know, I was in undergrad. It was phenomenal, but now as a grad student,
For
it's a
our
little
case,
subpar.
for international students, the
Biggest
main
sacrifice.
thing that we sacrificed our family. So we
Yeah.
are
Yeah.
Right.
Yeah.
away from our country.
We
and
are
then
exactly
not-
on the opposite side of the globe,
Yeah.
away from the
Yeah.
And then
family.
we are.
it is
we are
midnight
not-
beer, man.
We are not
It is midnight beer.
celebrating
Yeah.
festivals like
Yeah.
for
Yeah.
4 years
Yeah.
with our family.
I think mine's still, you know, girls versus family.
You cannot compare.
Yeah, I think hobbies is the big thing for me. But next one, sparse G. Why is the social boycott of the humanities students not a thing yet?
It's Sparsh Gautam.
That's what I said.
Oh, he's from India?
Yeah.
What does that mean? Like,
Sparsh means touch.
Why is the social boycott of,
So are you saying why aren't we boycotting like humanities in general?
like, why are we doing gen ed still?
I don't really have a comment for that.
Yeah.
well, I mean, I'd say humanities are pretty damn important. I mean, I'd say physics is cooler and more important in general, but those things are also very important.
Yeah,
You
there's.
can't, and like, as much as we hate gen eds,
Yeah.
it's like if your entire education was STEM, you wouldn't be a very well-rounded person.
That's
I
true.
feel like.
Yeah.
So-
And while not all of them are exciting, all your gen eds are exciting. I did take a couple myself that was like, oh, that's really interesting. Like,
Mm.
without taking my intro to philosophy course, I would be
Yeah, definitely.
like anxious all the time. I think.
Because of the diversity, there are lots of like Asian community, right?
Yeah. But what is this? How come all your group mates are Indians?
Oh, no.
Abhishek is the only Indian.
I mean,
He's the only one.
right now it's 50-50.
The camera cut off.
That's
I don't
a nice
know what
question,
part of the
right?
conversation was cut off, but basically only one person is Indian here. Sorry.
if anything else, that's what we have to make sure.
So I came here at like on 2015 fall. I was with Birendra. You know Birendra. Birendra is also from Nepal. Birendra and me came here, and then like so for my case, like I was applying a lot of universities. So I applied more than 15 universities
Oh my gosh.
altogether, and like I got like offer from NMSU, University of Arkansas, and University of Duluth, Minnesota. And then like so that was on masters, and Arkansas and NMSU was for PhD. And then I contacted here as the senior, and he recommended like so it's good.
And then you just told all your friends.
Yeah, and then we came, and then
Then they
like,
I mean,
followed you.
yeah, I have a different story because we know each other when we was in I'm in Nepal. So I got offer from 2 or 3 university, and NMS was the best among the ranking
I see.
among 3. And I know Vinod earlier before he came here, so it is easier for us to manage everything, right? To find the apartment, to find everything. So yeah, NMS is my first choice.
So the question says, so I guess this is specifically for Abhishek. What university in India did you graduate from?
I graduated from the MS University, Vadodara.
There you go.
There,
All right.
yes.
So basically, the short acronym for my university in India is MSU. I came to NMSU,
What is MSU?
Oh, you just added an
Maharaja
That's
Sayajirao
interesting.
University, Vadodara. So the acronym for that is MSU.
Yeah.
And then I came to NMSU, new
Just-
MSU.
New MSU, yes.
Okay, next one. What if you, after all your years as students, realize that you're not smart enough to carry on research in physics? Will you be able or willing to get a regular job with your knowledge of physics? P.S. I'm on the verge of deciding my career paths and immensely love physics. I'm kind of good at it too, but this question keeps haunting me. Well, I mean, you can either be you can be clever and lazy, or you can be kind of dumb like me but work really hard. So it's like if you're not the smartest person, I think you can still do well with physics by just sacrificing more hours to understand things. I don't think physics is just for smart people. I think it's for
the hardworking people.
Yeah.
now if you're smart and hardworking,
Then you should just quit.
Yeah, you'll be fine.
Yeah, I'd say like
Then you're
physics is, you're shooting really high. And so if you're not feeling like you're succeeding or happy at that really high point, it's really easy to step down and kind of go into other
Yeah.
STEM fields, or I mean,
Yeah.
there's a lot of
Yeah.
finance jobs, and it's just like physics just gives you a way of thinking that makes you valuable in a lot of fields. So I feel like if you're not succeeding,
Basically,
it's easy
if
to
you-
be mobile and
I mean,
go somewhere
you also
else.
don't. I feel like you're beating yourself up. You don't have to feel like you're not smart enough to do
Yeah.
physics.
Yeah.
You might just, for like me, I'm getting burnt out on it.
Don't
you know?
compare with others.
Yeah, it's not a matter of how smart you
It's
are.
more about
'Cause I'm
how-
a genius, but these guys, but
genius.
yeah, no. But no, I'm also kind of getting burnt out on it too. So I'll be fine. I'm confident that it's not a huge thing. You have to take a lot into consideration for what you want to do next. But don't beat yourself up because you don't feel smart enough for physics.
Yeah.
plus if you go towards the end of the PhD and then you're like, so say you're not, from your words, you say not smart enough to carry on research. Let's change that to just saying you realize research isn't for you for whatever reason. There's so many skills you'll have picked up on the way that are
Yeah.
applicable to other things. If
Yeah.
you're like physics is super computational, so now you have ways you can say you could be a data analyst or something like that, or say you work with Monte Carlo all the time.
So
or
I have
something,
seen many people who have changed their field after learning physics as well, because they obtained some knowledge like Monte Carlo simulation or something like that, and they went into data analysis part.
Yeah,
Which is pretty awesome.
Something you learned that you liked.
So you won't be over specialized. That's a myth. That's just not true because of how many skills you pick up along the way.
Yeah.
How do you combat failures, and what do you do when you feel demotivated? How do you combat failures? How do I does that mean how do I
How do you
adjust to
handle-
having them, or how do I
Yeah.
keep them from happening?
Well, I guess it's both.
Yeah.
Yeah, like
Mm.
how do you keep from failing? Well, I mean, I don't know if there's any particular way to keep yourself from failing.
I mean, be honest with yourself.
Yeah, and how do you cope with it? Well, just know that failure's inevitable.
It's like temporary, right?
Yeah, it's temporary too.
Yeah.
Inevitable, but temporary.
Yeah, sometimes I call my mom. She always gasses me up.
Oh,
She's
yeah.
like, "Oh, you're doing good. You're doing good still.
Yeah.
That wasn't much of a failure."
Or just talk to
Remember
your
this
friends
other
that,
thing
like,
you did good at.
that feel that they're smarter, that you're smarter than them. But,
Mm.
they always give you a good boost. They're
Yeah,
like,
my roommate too. He's like, I have no idea
Yeah.
the first thing that you do, on
Yeah.
a daily basis. Don't be
Yeah.
so hard on yourself. So
Basically-
remember how far you've gotten, basically.
For me, it's like physics is one of the toughest field of STEM, right? So if you are failing at it, that means you are failing from the top. Not the bottom. So if you have failed,
I don't know. Biology's kind of hard for me. Like that's a lot to remember.
yeah.
I mean, remembering and then understanding is different, right?
Yeah.
Physics
So-
is
Yeah.
it's really difficult.
Yeah, so
you
if
need
you
to-
are failing, that means you are failing from the top.
Not from
So,
the middle or
not
like-
from the middle or bottom. So still, there will be somewhere you will end up.
Well, what do you guys do when you feel demotivated?
Cry.
Right.
Yeah.
I take the time to kind of feel sad for a little bit,
Yeah,
or
No,
I used to watch
And
I,
then-
movies,
I have a
games.
really good story about this practical story that this happened to me after the first semester ended in the NMSU. I was really depressed because I did really bad in my finals and I got just B, and I was really demotivated. And after that we had the Christmas break. Then I knew that there will be the physics qualifiers on the 18th of January. So I told myself, no matter what happened in the finals, I am getting through the physics qualifiers in the first try. And then I keep studying for something like 12 hours, 16 hours a day
Oh, shit.
to make sure that I get through it.
Sorry.
I did about a half
And
hour.
for a month I continued that, and eventually it helped me a lot to come out of
Yeah.
the depression and
Mm.
demotivation.
So how could you manage like 16 hours per day to study in the break?
Yeah, I can.
Cocaine's a hell of a drug.
And I cannot
Don't
even
go out.
imagine.
See, I wouldn't handle my demotivation by being motivated. I would let myself be demotivated for a bit, you know, take some time for myself. If I'm not feeling it, then, you know, there's no reason, at least for me, to try and push myself to work if I don't want to work. Because I'll sit there at my desk and just watch YouTube videos. So
That basically just do some personal time, or like, I mean, I almost feel like the qualifying exam thing was also just like taking personal time. You're like, I'm gonna get this out of the way now, and I won't have to worry about it ever again.
yeah.
And yeah, I like messing around with some of the data I have and stuff, but like off topic, like not what I should be doing with it. I'm just like, I wonder what happens if I Fourier transform it. I don't know.
So do something that you are motivated to do instead,
Yeah, exactly.
until you're like,
Find
"All right, I'll
something
tackle
that you
this
are
now."
motivated to
but,
do.
But the big question, and I have to go tutor in like 7 minutes, so we got a little bit. So it's not the last question. Never mind. Is water wet?
Is water wet?
Have you seen that video?
Wet is a relative
Of the
term.
guy saying,
No.
you're only wet if you're out of the water, but if you're in the water, it's around
Okay,
the
so
water.
water can be wet if it's mixed with another liquid, I would say. Because wet sort of implies that it's saturated with something, but you can't have a material and also say that it's saturated with
What about
itself.
ice?
Is ice wet? Yeah,
So-
I'd say if it has any water on it,
Let's say
it'd be wet.
if it's in the liquid state, then yes. If it's not, well, gas can make you wet. Moving on. what amount of differential geometry can one expect in grad school? I'm thinking of switching from physics to math when I go for my PG because I want to really get into differential geometry. P.S. I'm doing undergrad physics now. Great videos, by the way. They've really helped me a lot. Well, I think as you go, so differential geometry is a different story, but as far as like tensor analysis goes, I mean, you use it all the time in like QFT. If you get into anything that's relativistic is spoken in the language of like 4 vectors and 4 tensors, because that way you know exactly how these equations transform. So in different fields where you have to either go into different frames frequently, like in relativity, or if you have to rotate systems a lot and you just need to know how the objects that you're working with change if you change the way you look at them. But that's really just, you know, transformations and maybe tensors. But
Is that
not
what we're
necessarily-
doing in
that's a
classical,
differential. So that's a differential geometry in 4 dimensions. If you are moving to mathematics, they will teach you for n dimensions.
Mhm.
So make sure keep this thing in your mind that if you move from physics to mathematics, they will be doing everything for the general n dimensions. In physics, it's probably 3 or 4 dimensions. So in physics, differential geometry is easier than the mathematics. In the mathematics, they will be going to all the higher dimensions and then start developing the theories.
I would say mathematics is not easier than physics.
Yeah.
Because like physics is difficult because of mathematics.
Yeah.
Right? Physics nothing
Yeah.
like so. While the interpretation is physics, all things are mathematics.
Like
Yeah.
physics is the special case
Yeah.
of math.
I feel like there's not a ton of differential geometry
Yeah, definitely
that
not.
I've seen. Like, so the transformations and stuff we were doing in
Yeah.
classical, I guess that would be considered differential geometry.
Well,
I've never
so-
studied it specifically, and I don't even really know exactly what it
The
is.
tensor
so.
stuff that you do
don't see
tensor
it.
stuff a lot in grad school, but it's always like you hardly ever work with very general tensors. Like in
Yeah.
classical mechanics, you have the inertia tensor, but it's only a tensor under orthogonal transformations. So if you were to go to different types, of transformations, there's no reason to think that the inertia tensor would still be a tensor under those transformations. So a lot of it is very, very specific. So it's not that big, unless you go into like general relativity or something. But even that's kind of a regular course in GR is not. If you understand the tensor calculus, it's not that
Yeah.
hard. What is your least favorite concept in your field and why? In your field,
Least favorite concept?
or thing that you deal with in your field.
It's,
Optics.
Optics.
I
Yeah.
like optics.
it's
Least
like
favorite.
classical. I don't like doing physics from 150 years ago.
I think they're saying in your research field, but maybe I'm
Oh.
wrong. So is there something that you deal with in your research where you're like, man, I gotta calibrate the spupedometer right now.
Oh.
It's really advanced
Yeah.
experimental equipment. Anything?
I don't like paper writing in general. It's like you see it, you know this thing's right or whatever, but then you have to put
Explain.
it together in such a way that at first glance, a random person in the scientific community is also going to understand and accept your explanation.
Yeah.
And going from you understanding it to convincing everybody else that you did it right is like, it's hard and I don't like it, but
As far as
it's essential.
As far as concepts in like a field, if I'm going into QCD more likely than not, something that I don't like about QFT is you describe these things as infinitely many, maybe simple harmonic oscillators if you have a free particle, and that you can do exactly, but then as soon as you want to introduce any kind of interaction, straight to perturbation theory. So my least favorite concept is the concept of if I want to actually describe something real, I have to describe it perturbatively, unless you're doing like lattice QCD.
Even weak rotation in the QFT is kind of not. I don't like that stuff in the QFT because sometimes it does not make sense, proper sense.
Yeah. Okay. Thermodynamics and Introduction to Astronomy book recommendations. This I can only do like a couple more.
Thermodynamics.
Kasanuan
I think Pathry is starting to grow on me for grad level.
for thermodynamics, it's not statistical
true.
mechanics, right?
I don't have a
There will
good.
be
Sears and
different-
Stalin
Yeah.
is what I like to use.
That's what I used, but they
I
don't,
like the Dickman and Zimanski.
Yeah, I don't have any recommendations.
What
I wish Kelly
is
was
the
here.
name of
She-
it?
she-
Yeah,
she-
it's
I'm
the
sure,
name
yeah,
of
sure.
I don't
what?
read.
Yeah, I don't know anything about intro astronomy.
Astronomy, no.
Couldn't tell you. I'll ask Kelly. Maybe I'll reply to this
astronomy's
later.
Just interesting enough to know, just to read about, so just
Yeah.
read articles. No.
I'll ask Kelly later what she
yeah.
recommends.
It's probably a good idea.
This one's long. Okay, so maybe this one will be the last one. Actually, is this?
Is it a question?
Is it just for me? If it's just for me, I'll read it later. Watching your vlogs. Okay, no, it's not. Watching your vlogs, I figured out more or less that physics at an advanced level dives more deeply into some crazy maths equations, weird symbols and whatnot. It sure is interesting solving these problems, but after a doctoral degree in physics and further, what significance will that weird and strange math have? How can it be applied? And is it really necessary for a theoretical physicist to work at academia and to teach students?
Maybe.
And at last, is it compulsory to tutor or have TA duty while being a physics grad student? Okay, so the physics, the crazy math, and the physics symbols. Well, the math almost always comes first, and so far in my experience, it's always been like in all of your classes, whether it's like the Bessel differential equation or something, it's like, the mathematicians already figured this out. So let's
200
let's just
years
look
ago.
at that. Yeah. So physics is like, there's math that's already there, and then physics arrives at this problem, and then that's the problem that ended up being solved by probably Euler or Gauss, however long ago. So the weird and strange math has a weird way of just being the thing that you need to solve a particular problem. And I think when I was talking to one of our professors, he was like, a lot of the problems now, we might just not have an answer because the math hasn't caught up yet.
Yeah.
Or it could be that we haven't found the right textbook with the ancient math equation. Is it necessary for a theoretical physicist to work at academia and to teach students? Well, if you're doing
Yeah.
theory, you've got to do research.
Well, I mean, I think they're asking, are they...
Like, do you
they
have to go into
teach?
academia if you get your degree in
Like, you
theoretical
could be a
physics?
theoretical-
No,
you could be a
okay.
because
theoretical
they need them at
physicist
every
the lab.
national lab.
Yeah.
Yeah.
Without teaching,
Yeah.
Because the experimentalists go, I don't know what to do with these equations, or like, I don't know what to do with this data.
Yeah.
For the experimentalist, they also don't need to know all of these stuffs. Like,
Yeah,
so
exactly.
If
So
you are
you-
going one field, then only one formula can work.
You have
for,
groups.
for his entire research or entire
Mhm.
But
life.
yeah, you almost always need a theoretician, like
so
on your
if
papers.
somebody is
Yeah.
doing crystallography, right?
Hmm?
So if somebody is doing research in X-ray related crystallography, right?
Mhm.
Few equations, few math equations will help.
Yeah.
And I think it's actually less common for a research physicist in general to also get a professorship somewhere.
Yeah, I feel like, just thinking about it off the top of my head, I feel like there's just as many jobs as professors in physics as there are positions at national labs.
Yeah.
Right? There's maybe, depending on the school size, 6, 7 professors in your department.
But yeah,
How many positions are at the national lab?
But if you are a theoretical physicist, I'm pretty sure industry won't be hiring you.
Yeah.
Yeah. You cannot go
There is
to
the
the
less
job.
chance to
Yeah,
hire.
you cannot go to the job where you have to wear the tie every day.
I
Yeah.
mean, they probably have to have a couple, but there's just not as
Yeah.
many of those
Yeah.
positions. Because I mean, there's still research and development that goes on in
But,
industry,
yeah,
and they
it-
need to have some sort of theoretical
Sometimes
backing.
industry just outsource their research to the university
That's
professors,
true.
and yeah.
That's true.
Instead of hiring the professor, just hire them for the particular
Mm-hmm.
project. That's it.
Like contract.
Yeah.
You could become a theoretical engineer. All right, so right now I think I have to go tutor now, so I'll probably pick this back up after tutoring with whoever's left.
Mhm.
So thanks everyone. If you guys are still here after tutoring or something like that, I know that you have to go to lab.
Yeah.
We'll probably pick this back up, and then I'll find out how to divide this video into probably 2 videos because we've got a lot to go. Okay, so see you afterwards.